Okay, so here is our fourth example. Notice our domain is still in degrees, so we shouldn't need to change our calculator mode. You guys probably had it set from the last example, even though we didn't need it. And you probably have noticed that the equations are getting progressively a little bit more complex as we go along. Well, this one's got a special pattern to it. Notice that there is a squared term here with tangent. There's a linear term with tangent over here on the other side. And then we've got this constant. This represents what we call a quadratic form. That's what I'm talking about. Just like from Algebra 2. Okay, so what we want to do first with this equation is we want to set it equal to 0, just like if we were solving a quadratic equation in Algebra 2. So we're going to do 2 tangent squared theta. We'll subtract that 3 tangent theta, the linear term, over to the other side, and we'll add 1 and make sure our equation is set equal to 0. Now what we're going to do over here on the left side is we're going to factor it by unfoiling. So I know that when I factor it, I get 2 tangent theta minus 1 times tangent of theta minus 1 is equal to 0. Now, if you're having trouble seeing the pattern of how I factored that so easily, try doing a little substitution, like letting x represent the tangent of theta. If I do that, my first term looks like this, 2x squared. My middle term looks like this, minus 3x, and then I have plus 1. And that's probably a quadratic that you guys are a little more familiar with factoring. But just remember, if you factor it with the x's, to substitute back in the tangent of theta. Now, because our equation is set equal to 0, and only because our equation is set equal to 0, we can use the zero product property to solve this, which means we can take each factor here and set each factor equal to 0. We're going to set up 2 little mini equations, just like in the previous problem where we square rooted. And yes, this factoring technique would have worked for example 3. You could have set it equal to 1, and that would have represented a difference of squares that you could have factored. So a couple different ways or methods that you could have used this. I cannot stress this enough to you guys, that this technique only will work when your equation is set equal to 0. If it is set equal to anything else, you guys can't use this technique. So let's continue. We'll solve each little mini equation now here. We'll isolate first the tangent of theta by adding 1 and dividing by 2. We're going to get tangent theta is equal to 1/2. And that means theta is equal to the tangent inverse of 1/2. All right, friendly ratio. We just have to figure out what quadrants in our positive rotation we're going to get angles from for a positive ratio, and that's going to be quadrant 1 and quadrant 3. Oh, but let me think. Actually, a ratio of 1/2 doesn't match a tangent function, so we actually will have to use our calculator. So let's see. When we put it into our calculator, we get 26.6 degrees. That's also our reference angle because that's the angle in quadrant 1. So if I add 26.6 to 180 in quadrant 3, I'm going to get an angle of 206.6 degrees. Okay. Now, over here for my second equation on the right, I'm going to isolate tangent theta first. That's going to equal 1. And then to isolate theta, I'm going to take the tangent inverse of both sides. And yeah, this is a friendly ratio, right? where I don't have to use my calculator. Again, I'm working with a positive ratio. So for this mini equation, I'm going to also generate angles from quadrant 1 and quadrant 3. And we know that those should be 45 and 225 degrees. Now, before we write our answers in our nice set notation, do we need to check any of these for extraneous solutions? Well, if we go back to our original equation, remember our original equation had tangents in it, and tangent is only undefined at angles that are multiples of pi over 2, 3 pi over 2, or 90 degrees to 70 degrees, and we didn't generate any of those angles when we did our solutions. So this time we know we don't have to check for extraneous solutions. We'll write our answers in our set notation here from least to greatest, and you have just solved a trig equation in quadratic form where we had to use a little bit of factoring. Now, what do you guys think you might have to use if we couldn't factor that quadratic form? Think about that. I'm going to ask you for the answer when I see you next time.